So in this video, we are going to discuss about the significance of the vector clock, what is vector clock, and the causal ordering, as well as the algorithm which is used for the causal ordering of the events which are happening at the different processes. So we will be discussing all these in this video. So why we are in need of vector clock? Because of there are certain limitations of the Lampports clock. Because in the Lampports clock, you have seen that if any event has happened before the second event, A and B, A is happening before B. So of course, the time stamp which is meant for A event should be less than the time stamp of the B event. The limitation regarding the Lampports clock is that if A is happening before B, then automatically it means the time stamp of A is less than time stamp of B. However, the reverse of this is not necessarily is going to be true, and that is going to give the indication that in the Lampports clock it has this kind of limitation, that the limitation is if time stamp of any event A is less than time stamp of any event B, and of course there is no signal which is indicating where there is no signal by which it is indicating that A is causing B, then it will be very difficult to find out whether A and B are causally related or not. It may be possible that A and B may be causally related or may not be causally related. The example is like this, that the process P1, there is event number 1, which is E11, which causes another event E12. And that is why the time stamp of the first event is 1 and the time stamp of the second event is 2. And this event E12 is sending a message to process P2, which is being received at timestamp 3 at P2. So by this we can say that E11 is causally related with E22 because A11 has happened before E22, as well as the timestamp of E11 is less than the timestamp of E22. But if you take the case of E11 and the events which are happening in the process P3, suppose I'm talking about the event which is E32, which is happening in process P3. Now, the timestamp of E11 is 1 and the timestamp of E32 is 2. So since the timestamp of E11 is less than the timestamp of E32, but Lamport algorithm, Lamport suggestion is not able to relate that whether E11 is causally related with E32 or not. It may be possible that E11 may be causally related with E32, or it may not be related to E32. So just because of this limitation, we have to find out the solution so that we are able, by looking to the timestamp, we are able to judge and say that this event is causally related with the another event or not. Because it happens just because every process which is running on the different computer system having its own clock, and they are independently advancing. The clocks are going to be independently advancing due to occurrence of the local events which are happening in the process which is running on that particular system. So there we are not able to distinguish between the advancement of the clock due to the local events which is happening in the processes until unless we have exchange of the message between the processes. So in Lampport's clock, the using the timestamp which is assigned by the Lampport's clock, we cannot reason about the causal relationship between the two events occurring in the different processes by just looking at the timestamp of the event. So that is why we need another system, another clock, and that clock is vector clock. The good thing about the vector clock is it is capable to decide whether the two events are causally related or not causally related just by looking the timestamps of the two different events happening in the two different processes. In this vector clock, the vector clock is being represented in the time domain and it is actually the representation of the set of n-dimensional non-negative integer vectors, meaning thereby how many elements will be there in the set of n-dimensional, where n stands for the number of processes which are running parallelly. So n is the number of processes. So if there are 3 processes, then they will be represented by 3 timestamps. So that is why it has been said that it is represented by a set of n-dimensional non-negative integer vectors. Now, whenever we provide this vector timestamp, it is used to provide, it is going to record the causal relationship between the events, and that is why by looking to the vector timestamp, we are able to say whether the events are causally related with each other or not, and how it is being done. Now, each process Pi, where I may be 1, 2, 3, depending on what the process is may be, where each process Pi maintains a vector Vti from 1, 2 up to n, where n is the total number of the process. So each process maintains the vector of each process, where Vti, the entry which is being done in this I, is the local logical clock of Pi, and it describes the logical time progress at the process V. Vtij represents process Pi's latest knowledge of the process Pj local time. Pj is the process, and the entry which is being done in the process Pi will be governed by the local time of the process Pj, who is going to send any message to the Pi. Now, the algorithm works in this fashion that if Vtij is equal to x, suppose Vtij is equal to x, the timestamp j is equal to x. It means then the process Pi is able to know that local time at the process Pj which has progressed till x, meaning thereby if there is a value 1, it means the local process has just initiated one event. If local time, if the process, if x is equal to 2, it means before that one event has occurred in the process Pj. Now the entire vector Vti is going to constitute the Pi's view of the global local time and will be used to timestamp the event, as well as the process Pi are using the two rules, and with the help of these two rules, they are going to update their clocks. Now, the first rule for the vector clock specifies that before any event is being executed at a particular process Pi, this process Pi updates its logical local time as Vti I is equal to Vti plus D, where the value of D is greater than 0. Normally, the value of D is equal to 1. Suppose the meaning of this rule is very simple. Suppose we have a process P3, and the process P3 has just initiated its first event. Before the first event has been initiated, the vector of that process will be 0, 0, 0. And after the first event has been initiated, it has to increment it by 1. That is the value of D. And the second rule says that if event A is sending message M to a process Pi, koi bhi event, any event A which is happening in any process, and if that process is sending a message M to another process, then the message M is assigned a vector timestamp, and that vector timestamp will be represented by K. That is where the K is the local timestamp of that process where the message M has been initiated. And when that message is being received by another process, the vector time of that process is updated as follows with that particular rule. And that rule is, for all values of K which is available in this VTK, VTIK will be the maximum value of VTIK and the timestamp of that message. Of course, the time associated with a particular event is the value of the vector clock of its process when the event is executed. It will be more clear if we go ahead with a certain example, then these two rules are going to be more clear. Now, suppose this is the evolution of the vector time. We have three processes, P1, P2, and P3. And initially, this process P1 has no, it is being initialized by, just wait, it is initialized by so initially this value is actually 0, 0, and 0. P1. Similarly, this initial value of the process 2 is also 0, 0, 0, and initial value of P3 is also 0, 0, 0. These three values are 0, 0. Of course, it is written in the vertical form. You consider it as a 0, 0, 0, 0, 0, 0, 0. So all these three, initially, the process is initiated with 0, 0, 0, 0, all three processes. Now, since three in this vector, we have three elements. Why it is three elements? Because n number of processes or n number of elements, which is being maintained by each process in the form of a vector time. So, the first component of this vector time represents the process P1. The second component of this represents the process P2. And the third is the timestamp of the P3. So initially it is 0, 0, 0. Initially it is also 0, 0, 0. Initially it is also 0, 0. Now at a particular moment of time, P1 has initiated an event. So P1 has initiated an event, and before that no event has occurred. So it means it will be going to update the vector by value 1. So 0 will become 1 because it is the first event of the process P1, and P1 does not know about the processes P2 and P3 that what the events are happening. At this particular juncture, P1 is knowing that it is 0, 0. And after this event, the second event occurs in P1, and that event, it is going to update by the rule number 1, that it is going to update, and it will update it by 1. So since the first component of this vector is the representing the events happening in the P1 process, so 1 will become 2, and the rest will remain as it is as 0. Now the process P1, this event, suppose this event is known as P12. This event is sending a message to process P2. So whenever this event which is happening in process P1 is sending a message M to another process P2, it will send the timestamp of this process, of this event, as 200 to the process P2, so that P2 can update its local time. P2 will be able to update its clock vector. Now, before this sending of the message is happening, there is an event which has occurred at P2, and this is the first event which is occurring in the process P2, and second component is representing the process P2 events. So second content will be incremented by 1. Similarly, in P3, the third component will be representing the local time of P3. So the whenever first event is occurring, so it will be updating it as 001. So here the first event occurs, so it will become 100. In this, the first event occurs, so it will become 010, and this event occurred in P3, so it will become 001. Where the first component always represents the local timestamp of P1. The second component will be representing the timestamp of P2, and the third component will be representing the timestamp of P3. So when this event P12 is sending a message to the process P2, it will send along with its vector time. It will send along with its timestamp, and that timestamp will be the timestamp or the vector time of this occurring of this event. So it will send 200. Now the rule 2 will apply, because rule 2 says that if an event is sending a message, then we have to find out the maximum value. So what will happen? The event is having 2 as the first component, second component is 0, and the third component is 0. It is the timestamp which is representing the vector time of this event. So out of 2, and the current local vector time is 0. So out of these 0 and 2, we will find the maximum value, so it will be 2. Since it is the second event which is occurring in the process P2, so this 1 will become 2. And third component, we will compare this 0 with 0. So we will find the maximum, we have to find the maximum of these 2. So this will remain as it is 0. Now, the process P2 is going to occur another event. And when this event is occurring in the same process, it will apply rule number 1 to update its local time in the vector set. So the first event occurred, so it becomes 1. Second event occurred, so it becomes 2. And the third event has occurred on process P2, so it will become 2, 3, and 0. This 2 will be updated by 3. Again, I am repeating, the second component is representing the vector time of happening of the event in the same process. So it will become 2, 3, 0. Now this event, which is E23, is sending a message to the process P3. It will send this message it will send this E23 will send this message to the process 3 with this timestamp, that is 230. Now this rule 2 will be going to apply over here. Why? Because we have to take the 0 and 2, maximum of 0 and 2, so it will become 2. The maximum of 0 and 3, so we will take 3. And since one event has already occurred locally in process P3, so it will be automatically incremented to 2. So it will not be considered 0, it will automatically will be 2. So it will become 2, 3, 2. Now the next event which occurred at process P3 is in the same, is the third event, and the third component of the vector is representing the happening of the event in that same process. So this is the third event, so it will become the vector time, or the time stamp of this event will be 2, 3, 3. Now the fourth event has occurred on the process P3, so it will, the time stamp will become 2, 3, 4. So here it is 1, 2, either 3, and it is 4. It means the fourth event has occurred in the process P3. Now this process P3, fourth event, is sending a message to the process P1. Now it will send this message to the process P1 with the time stamp, vector time 2, 3, 4 to the process P1. So when it is being received, it will update its local time. P1 will update its local time. And how it will be updated? The first component belongs to the process P1. And since this is the fourth event which is happening, because it is already 1, 2, 3, so it will become 4 because of the fourth event of the process P1. And now it will now compare this 3. Now rule number 2 will be going to apply. It will compare this 0 with this 3. So maximum of 0 and 3, so it will become 3. Maximum of 0 and 4, so it will become 4. So in this way, the vector time. Now the next event, fifth event, which is happening in the process P1, so automatically the first component will increment 5 and rest will remain as it is. Now this, with this time stamp 5, 3, 4, the fifth event of the process P1 will send a message to the process P2 with this time stamp 5, 3, 4. Now this is again the first, second, third. This is again the fifth event of the process P2. So whenever we have to update the vector time or the time stamp of the process P2 of this particular event, which is receiving a message from the process P1, first of all, it is going to compare the first component with the actual time first component of the process P2. It is 2 and it is 5. So automatically we have to take the maximum, so it is 5. Since it is the fifth event, so it will be, this 4 will be updated to 5. And out of this 0 and 4, we have to take the maximum, so it will become 4. And the next event which is happening in the process P2, it will be automatically, since it is 5, 5, 4, 5 will remain as it is, 5 will be updated to 6, and 4 will remain as it is. So this is how the vector time is being evaluated. And so it is also going to signify that the event is causally related or not. Now, this event, first event of P1, is causally related with the second event of P2 because of the entries which has been made. This third event of P2 is causally related with the, so it means this first event of P1 is causally related with the second event of process P3, and so on. And so this event is not causally related with this. This event is not causally related with this. This event is not causally related with. So in this way, the vector time is going to give the information about the presence of causal relationship in between the different events which are happening in between the process, just by, not by only the Lampports timestamp, but by applying the vector timestamp, we are able to judge the event to be causally related or not. So what is causal ordering of the messages? Now, as far as the causal ordering of the message is concerned, uh, it is going to deliver a message to a process only if the message immediately preceding it has been delivered to the process. Meaning thereby, suppose there is a process P1 and two, it has sent one message to the two processes. So whenever it has sent one message to the two process, it has to be received, that message has to be received by all the processes before they are going to receive any other messages from any other processes. Why? Because it is the first event which has happened at a particular process, and it has to be delivered before it is being delivered before it is going to deliver the other processes. So so the meaning of causal ordering is that if a message has to be sent by a process, that message has to be received by another process before, and before that all the messages of which has to be received by the process has already received. Otherwise what will happen? Otherwise it will try to buffer it until the message immediately preceding it is being delivered. So causal ordering is actually, if sending happens, send operation, this message is being sent, if it happens before sending of M2, there are two messages, M1 and M2. If M1 is happening before sending of M1 is happening before the sending of M2, then every recipient of both the messages must receive M1 first, and then it should receive M2. And as far as the application of the causal ordering is concerned, it is used in the replicated database system in order to maintain the consistency. So what is, you try to learn what is causal ordering. Suppose this is an event which is happening in P1. This is another event which is happening in P1. And this event is actually sending a message M1. And this event is also sending a message M1. Now this is sending a message to the P3 process, and this is sending a message to the P2 process. So if they are sending M1, this M1 which is sent by this process P1 to P2 and P3, they must be received before, and before receiving this message M1, all these processes must have received all those messages which had happened before sending of the M1. M1 को भेजने से पहले अगर P2 और P3 प्रोसेसेस में को पहले से कोई मैसेज भेजा गया होगा, तो पहले वो मैसेज P2 और P3 पे रिसीव हो जाना चाहिए. That is the meaning of causal ordering. So when this is sending a message M1, it is being received by P2. Because why it is being received? Because before this message, another message was created and it has been received. So M1 is being received. Now this event is causally related to another event which is happening, and this is sending a message M2 to the process P3. And this process P1, this event has sent a message M1 to the process P2. Now sending of this M2 happened after sending of M1. So sending of M2 must be received. M2 must be received by P3 after the receiving of M1. But here it is not so. M1 is received later and M2 is received prior. So what we have to do? This should not be allowed. And what we have to do for this particular purpose, this M2 message, before it is being delivered, it must be buffered at the process P3, and it should be delivered after this first message is being received by the process P3. So for that particular, this is another example of the causal ordering. Suppose this is the event which is happening E11, and this is sending a message M1 to the process P3. So it is sending a message M1 to the process P3. So process P3, before receiving M1 by process P3, all those messages which had happened before, if it has been sent to P3, it must be received. Otherwise, it will not be received. So there is no message before M1 which is being sent to process P3. So M1 message is being received by the process P3. Now, second event occurs when process P1 is sending message M2 to the process P2. Since there is no message which is sent to P2 before this M2, so P2 is going to receive this message M2. And after that, E22 has created, the second event of the process P2 has created another message which is M3. And this M3 is sent, and it is going to be received before the M1 is going to be received. And this is going to breach the causal ordering of the message. Why? Because M3 is created after receiving M2. And M2 is created after M1 is created at E11. It means this M1 is causally related to M3. If M1 is causally related to M3, the recipient must be receiving first M1 and then it must receive the M3, because M1 has happened before M3. So the time stamp at which the process P3 is going to receive the time stamp of receiving of M1 must be less than the time receiving of the message M3. So that is why, but what is happening here at this event E22, M3 message is going to be received by the process before it is going to receive the M1. But causal relationship says that any message which has been meant for a particular process and has been the cause of the event which happened before that, it must be received first. So what will happen? M3 will be buffered, and it will be buffered till the M1 is being received. And when M1 will be received, then only the M3 will be received. So what is the relationship? Sending of M1 causes the sending of M2. Sending of M2 causes the receiving of M2. And receiving of M2 has caused the sending of M3. So sending of M1 and sending of M3 are causally related. And when two messages sent to a process are causally related, they should be received in the same order. They should be received in the same order, meaning thereby first M1 should be received and then M3 should be received.